Do you own an old Mercedes or any other old car that uses this or this? If you do, it would be beneficial to you to help understand or help better understand the internal workings of the Bosch K-Jetronic fuel system. In this video, I will fully explain how they work, what each of the parts are called, and whether you should be worried about these systems. In front of me, I have one 8-cylinder and a 6-cylinder. Although these two cars share the same systems, they both work differently. We'll first start off at the back of the car at the fuel pump, which isn't mounted in the tank. Instead, it's mounted right there. This is the fuel pump assembly of the K-Jetronic fuel system, and we start off here. This is the fuel feed line that goes into the fuel pump, and then the fuel pump pressurizes it and sends it to the front. But that is not the case with this fuel pump assembly. Fuel goes in, fuel pump pressurizes the fuel, and it sends it through the fuel filter and to the front of the vehicle. But we have something extra. This is a fuel accumulator, and on the K-Jetronic systems it is a bit different. This is a different one from a different model, but they both serve the same purpose. These fuel accumulators basically just depressurize the fuel system. So when you switch off your car and you leave it to sit, this is in charge of depressuring the fuel system to enable the best start possible when you go back and start it. When these fail, you'll typically see it bleed too much pressure in very little time, which will then result into hard warm starts or difficult warm starts. What that means is your car will take a long cranking time to actually fire over when it is warm. Now you'll get two different types of fuel pumps. Sometimes you'll have two fuel pumps, and then other times you'll have one fuel pump. Two fuel pumps are usually found on the cars with bigger engines, like your 500 SEs, your 500 SCCs, and sometimes your 560 SECs and SELs. But generally, most cars use one fuel pump. On the K-Jetronics, you'll see that when you jump into the car and you turn the key, the fuel pump won't come on. But when you crank the car and actually try to start it, the fuel pump will then come on. This is due to the internal workings of the fuel distributor. When the car is off and the fuel accumulator at the back bleeds off the pressure, this will have little to no resistance. However, when you turn the pump on and it pressurizes the system, this will in turn be hard and difficult to press down. You'll feel resistance when you press down on the pressure plate. This is what one of the K-Jetronic injectors look like. Now, it doesn't have an electrical plug, and there is a reason for that. This is a continuous injection system, which means it's always spraying fuel into the combustion chamber. It never stops. So therefore, if there is a greater amount of pressure, so I made a mistake during this part of the video while explaining why the fuel pump doesn't come on when the key is turned on. That is because, again, the fuel accumulator bleeds off the pressure in the fuel pipe to maximize the best starting. So, and also because the injectors are spraying all the time, that is also another reason why the fuel pump doesn't come on when the key is turned on, because then that will give you a rough start because it's essentially flooding the engine. Another point to mention about the sensor plate, you can adjust the height that it sits at rest by by using I think it's a 5 millimeter Allen key to adjust the lambda as well, the air fuel ratio. So clockwise, turning your Allen key clockwise enriches the fuel mixture, and counterclockwise leans it out. So just like a carburetor, you can adjust the air fuel mixture right here. But if you do adjust the air fuel mixture to, for example, to get more performance or better fuel economy, you will experience a difference whereby you're starting your vehicle, whether it's cold start or warm start, you may see smoke out of your tailpipe because it's running too rich of a fuel mixture. So just be careful when you adjust this. There is a factory setting with this plate, and there is a way to adjust it. My way is I would take off the top fuel pipe, I'll jump the fuel pump to make it run all the time, and I'll just press this plate down about 2 to 5 millimeters, and I would want to see fuel rushing out when I get to that 5 millimeter mark, and before that it shouldn't come out. So that's my way of adjusting these fuel distributors. It's worked in the past, it works now, so if you want to use that method, you can. Now, some of you may be confused at what this plate actually is. Some of you may think it's a throttle plate, but when I move the throttle linkage, this doesn't open. Instead, the throttle is actually down there, inside that coupling. This is like an air meter. The more throttle you apply, the more the plate goes down, and there's a little plunger on the fuel distributor that gets pressed up when this plate goes down. I have a spare fuel distributor here to help better explain what that pin is. So this is the pin. So what I meant by when this plate gets sucked down, this gets pushed up. So think of my finger as the plate. When more throttle is applied, the plate moves more down, and in turn it presses the plunger more in, which opens the valve to release more fuel among these ports. And then when the plate closes, this goes up. I don't know if you guys can see. This goes up. Now obviously it won't go up right now, or it does, but normally it wouldn't when there isn't any pressure in the system. So when there is pressure, it's more faster to come up and go down. Then when you come to the front and the fuel reaches the front of the distributor, you can easily tell which is the return and which is the pump line. How you tell which one is the return line? You would want to find this nut, and wherever this nut is connected to, that is the return line. I will explain to you why that is. So I forgot to include in the video why or what that nut does. So that nut basically, it's like a long shaft with a spring and some shims that help control the return pressure back to the tank. And it also has O-rings to seal those 3 pipes chambers from each other, so that you don't get any loss of pressure, number one, or fuel doesn't flow where it's not supposed to flow. So that's really all that nut does. So if you are losing fuel pressure instantly when you turn off your car, one of the culprits may be the O-rings on that nut. With the fuel distributor, fuel goes in through the bottom, goes up through a small channel right over here, through this pipe, and down to the warm-up regulator or fuel pressure regulator. With this fuel pressure regulator, it's in the name. It controls your fuel pressure. However, it controls your return line pressure, which is what this pipe is doing over here next to the return pipe. So the warm-up regulator, as your engine goes through the duty cycle, it increases the amount of fuel pressure going through this return pipe back to the tank, therefore decreasing the amount of fuel pressure going to the injectors. When the fuel enters into the fuel distributor from the warm-up regulator, it goes into the fuel distributor and through each one of these ports. And what the fuel distributor does is it equally distributes fuel among these 8 ports based on the volume of fuel that is going into the fuel distributor. That can be adjusted by these nuts over here. So you open them up and there should be another Allen key nut that opens and closes the amount of flow. Now remember, if you decrease the amount of flow going into this port here, it will increase the amount of fuel going into the other ports. So it is important to not mess with any of these adjustment screws if you do not have the proper experience for it. So if you suspect your fuel distributor is a problem, take it to a specialist or get a known good fuel distributor. It's not worth it to try and mess with these adjustments to try and fix it. The result will often prove fatal to the fuel distributor. So either get a used one, take it to a known good professional, or if you really have that much confidence, try and rebuild this unit yourself. But stay away from these adjustment screws. When rebuilding your fuel distributor, do not take them out, because then you will have to rebalance the fuel distributor, and that requires special machinery. There is, however, another pipe going into the return side of the fuel distributor, but this pipe has nothing to do with the return. It instead goes up to here to this device, which is called a cold start injector, and it's in the name. It sprays fuel when your engine is cold to help start it better, because if you didn't know, your engine requires more fuel to start when it is cold rather than when it is warm. If you really think about it, these fuel systems aren't that bad. When they work, they are actually really reliable, but they can cause problems if you let your vehicle sit. So it's always best to drive your vehicles. If you drive your vehicle, the K-Jetronic fuel system will never fail. They will always work. And these parts don't really have to get serviced. If treated well and driven and kept moving, they will last longer than the lifetime of the vehicle. Now, at the start of the video, I said that these two fuel systems are different compared to the 8-cylinder and the 6-cylinder. But there's really only one difference, and that is this thing here. This is an electronic idle air control valve which regulates your idle. However, with the straight 6s, it's completely manual. There's the adjustment screw down there, and then there's another pin that opens and closes based off your water temperature. So that pin or that valve opens and closes based off how warm or cold your coolant temperature is. But other than that, there is no real differences between these two systems. If you know the basics of how these systems work, it will help you better understand what your car needs and how to fix the problems it has. This video was meant to be a short educational video as to the basic runnings of the K-Jet fuel system. There is more to it, but this is just the basic idea of how they work. If you have any questions, feel free to put put them in the comments and I will happily answer them to help put your old Mercedes back on the road. And yes, this car is missing a grille. I do have it. It's currently getting fixed because one of the tabs are broken, so I did repair it. Here's the grille. There's the repaired spots over here and there. I still need to sand it a bit more and then I'll just spray it and then it will be good to go back on the car. If you enjoyed this video, feel free to like and subscribe to help show me that you guys actually enjoy these videos and to motivate me to post more mechanic videos of me actually fixing these cars and not just talk about them. With all that being said, thanks for watching the video and I'll see you in the next one.